So welcome to the beginning of the second series of seminars on music and data. This is part of a research network that we are running from January. We are about halfway through, looking at music, data, and kind of the gaps between them with the focus on creative musical practices. So I'm really delighted to have Atau Tanaka here, who has been showing us how to do it. So over to you, Atau.
Great, thank you, Oded, and to Federico and the members of the Datasounds, Datasets, and Datasense Research Network. I'm very happy to give this talk, especially since we had a kind of a false start a few months ago when I had some trouble making the original engagement. So thanks for the second chance. And so my talk, I will start to share the screen as I introduce myself, is called Human Learning versus Machine Learning, looking at machine learning applications in music, but not forgetting the human side. Indeed, my own work is as a composer and performer. I'm a professor of media computing at Goldsmiths and also a member of the Bristol Interaction Group. I'm running a research project currently funded by the French Agence Nationale de Recherche at the Maison de Sciences de l'Homme in Paris Nord. And in all these settings, I'm interested in our live interactions between the human body and machine systems. And increasingly, machine learning is taking on a certain importance in all this. So with that, I will share, find the right slides to share. Yeah, desktop, that's not quite desktop, desktop 2, where is it all gone? So then the question is, if I share this, no, that's desktop 1. Okay, well, hold on. Yeah. Okay.
Yeah, all working.
All working? Good. Okay. It's not quite the arrangement that I wanted. Hopefully you see everything and nothing's being blocked. Just let me know, because I don't think I see the chat window anymore. So if there's anything going on, please interrupt me. I'll be playing some video and some sounds as well, so hopefully that will go smoothly. So here we are, human learning versus machine learning. Okay. So yeah, I think it's for especially an audience such as this, we've noticed that AI is very much in vogue at the moment in research. And not just in academic research, but we've seen the take-up of AI and a real fascination with artificial intelligence in the cultural sector, in the arts. And so this is evidenced by major exhibitions that we've seen in the last few years in top-level venues like the Barbican in London, where they had the More Than Human exhibition. This is also coming to the music sphere, and increasingly festivals such as Ars Electronica, the Sonar Festival in Barcelona and elsewhere are running seminars, symposia, concert programs, looking at the intersection of AI and music. So really, it's all around us now. Meanwhile, many of us are using code libraries made available, in some cases by giant corporations like Google, that are able to help us in some ways with their armies of engineers and their enormous data sets, by making available libraries, code libraries like Magenta, that allow us then to access relatively easily the power of deep learning. And with that, we've started to notice all sorts of kind of psychedelic visual mashups, sometimes that are taking the artistic style of famous painters such as Van Gogh and mashing them up or morphing them with other styles and so forth through techniques of style transfer, generative adversarial networks, etc. Similarly, in music, with Magenta, little examples like NSynth from Google allow us to explore then the application of machine learning and AI technologies to music synthesis, music composition, etc. Meanwhile, we start to hear that corporations like Spotify may be using AI technologies to replace human musicians. Okay, and it's an old colleague of mine, Francois Pachet, who worked alongside me at Sony Computer Science Labs about 20 years ago, went on to become director of Spotify Research Labs in Paris, and with his European project Flow Machines, started to create machine collaborators for music composition of pop songs. Of course, this kind of news is picked up by the press, and they start to ask, are there human musicians at all? Are human musicians being replaced by AI? But this is journalistic reporting to make things either fearful or exciting. And if you actually talk to the researchers behind this work, Francois Pachet himself says, well, he is himself a jazz guitarist. He's not looking to replace a human musician, but to make better collaboration tools between human musicians and machine systems. But increasingly, in the world of popular culture, these AI technologies are being taken up also into areas of social media, virtual and immersive technologies, and young artists are starting to create new forms, such as virtual idols. And indeed, this virtual pop star, Yona, doesn't exist as a human being, is a complete virtual fabrication, but has millions of fans and has performed in the Frobisher Auditorium at the Barbican. So where is this all going? Well, we can worry about what's happening at the bleeding edge, worry about what's happening to human musicians, but really it's to think about the fact that these technologies, that artificial intelligence was certainly not invented yesterday, that there's a history to this science, and that all the work and experiments of previous researchers accumulates to a certain body of work, quite often then captured in data sets. So in the visual world, if we're to do deep learning on visual media, we benefit from data sets like ImageNet, which has been going on for 10 years now. And so artists like Trevor Paglen are able to contribute to the data set, draw on the data set to create his personal visual artwork. Of course, this then brings up new debates about whether technology itself is neutral. Okay? And so we've read in the press reporting on the tagging, the automatic tagging of image systems that may have inherent bias. Okay? And so then these become very important issues for us to be aware of. Okay, that the technologies may be doing something that is not as objective as we imagine, and our work, both technologically and creatively in this field, needs to be aware of these issues. So music and AI, to get closer to our very topic, is starting to become an area, a research area of itself, that we see in places like Frontiers, adding a research topic in the discipline, and indeed research networks like the Datasense network. Okay. We have also humanities scholars starting to study the development of this area. So we have Georgina Bourne, an eminent cultural anthropologist of music, who is now running a major European project looking at music AI. And I think Bob Sturm, who is in your network, is one of the scientists working with Georgina on this project. I attended and took part in a conference she organized 3 years ago as a kind of kickstart to her thinking in this area. Around that time, I myself took part in a research network, this one funded by the Engineering and Physical Sciences Research Council, the EPSRC. We ran what was called a Network Plus on human data interaction. That ran for 3 years, just wrapped up, and it had in its consortium Goldsmiths, the University of Nottingham, Edinburgh, Glasgow, and Imperial College. Okay. Music was not the only theme in it. I represented a theme of art and culture amongst 8 other themes that include public trust, beyond smart cities, HDI in mental health, Internet of Things, and then critical issues such as social justice, ethics, surveillance and resistance, and the theorizing of human data interaction. So the cross-cutting concepts that we had across those 9 themes, okay, were high-level, what we call tenets or principles that describe, we hope, all human data interaction if we are to take it seriously, if we are to think of it in a robust way. And the tenets that we proposed were legibility, agency, and negotiability. Legibility being the readability of data. Okay, is it readable to humans? Agency is the empowerment that human users may have on data systems. Can we be active agents, okay, in conversation with the data system? And if we are, then is there a negotiability? Okay, do we have to accept what the AI system spits out and tells us on face value, or do we have the possibility to feedback and negotiate with the system? So these tenets are what we consider to be the top level essential principles that would describe, that would be characteristics that we would like to have in a robust HDI system. Now, my role representing the arts and cultures was to map those tenets onto creative activities of art and music, okay? And to, if we are generating style transfers in the paintings of Van Gogh, if we're generating new forms of music, okay, or partners in composition of music, okay, can these tenets, legibility, agency, and negotiability, help us in conceiving these systems, help us in working with these systems? Do these tenets then provide a lens through which we might imagine meaningful creative projects that deploy and use technologies of artificial intelligence and machine learning? So the Network Plus HDI has just wrapped up. Unfortunately, we were subject to the COVID lockdown. A lot of things took place long distance, but the upshot of it is that instead of having a final showcase meeting, we produced a nice video. If you go to the HDI website, you'll see a 10-minute version of the video that describes the network. I'm not going to bore you for 10 minutes and risk playing a jerky video on YouTube, but I'll play the 1-minute teaser and then a second video that focuses on my theme. So let's see if this works, and please tell me if it doesn't.
The HDI Network Plus is a project that was funded by the EPSRC with the intention of creating a sort of a broad network of people focused around a particular theme, in this case, human data interaction.
The HDI Network Plus is in effect a large collection of many small projects. We've funded people in all different universities and institutions across the UK to look at this issue of how people interact with data and how they interact with other people through data-intensive systems.
I think the biggest problem that we are facing is the excessive and unbounded data collection that happens today in order to build models in the future.
We started thinking about this network in 2017. At that time, new things like the GDPR laws just came into action. It's been a 4-year process, and in that time, the world has changed. Okay, so that really is a teaser. In some ways, for a specialist audience such as yourselves, it says basic things that we already know, but hopefully the 10-minute video may be of interest to you. I'd like to now, however, take just an excerpt from that 10-minute video where I speak about the arts and culture theme.
The HDI Network Plus, the HDI.
Here we go. So I'm theme lead for the creative industries. That's to say, I support the projects that cover arts, culture, and music in the HDI network. Music has always been a harbinger of new technologies. If we think about the music industry, data is there in recommendation engines and our personal profiles. So it's part of music listening and music consumption. But when you talk to composers and researchers, data also exists at the creation of music. By putting these into interaction, we're starting to see some of the tenets of HDI, agency, negotiability, legibility, emerge in the spectrum of music, from music creation to music listening. So by being able to support a suite of projects, we were able to see what's emerging from the research and creative communities in this area. We have Nilima Sailal from Nottingham, who worked with the BBC to make the cross-media recommender. So this is perhaps the classical case of a music recommendation engine using personal data, personal musical tastes. She was interested to link profiles across different services, from Spotify to BBC and others, but all while keeping privacy. Anna Zambo from De Montfort University and her project Atau uses metadata in music. So data that might be used for a recommendation engine to say, if you like this, you might like that. But instead, she uses it in the practice of live coding. That is to say, she does music information retrieval, extracts the metadata from a very large corpus of music, and then plays them as a performer through live coding.
I'm one of the co-investigators in.
So let's see if I can move on to the next slide. So that was the excerpt from the 10-minute video where, as you see, I talked about music and the projects, 2 of the projects we supported, and we had 8 in total in that area. Okay, so now really, so that's the research network that I just finished running, where we developed a lot of this thinking, certainly behind the 3 principles and tenets. And now I'll talk a little bit about my research. And here then comes the human element, the question then of, if there's machine learning, is there human learning? So I am a performer of interactive gestural music. I'm trained as a composer, but I go on stage and perform my own works. So creative practice is on stage, it's in performance. But because I'm working with physiological sensing, biomedical technologies, and technologies that capture states and movements of the body, the research area is in an area of HCI called embodied interaction. Okay. So all this comes together to then create a form of what I call music-human-computer interaction. Now, the specific technologies I use, I mentioned biomedical technologies. In particular, I'm working directly with electrical signals of the body, so bioelectrical signals, electrical impulses created by the central nervous system, in this case, in muscle contraction. So I'm picking up the electromyogram signal as the brain commands muscles to contract. They emit electrical pulses that are able to be picked up by electrodes, digitized, and then used in a musical interface. So then there can be a whole talk about that, and I've been doing this all my career, over 25 years. And in that time, I've always been thinking, okay, Is it time to adopt some AI or machine learning technologies? Can a neural network help me in what I'm doing? And it took about 10 years really to think about this and to find a way to make robust musical interaction. And I've been doing this now for several years. So the question then, in slowly coming around to this, was how to adopt AI, or just in this grammatically incorrect, but hopefully somewhat elegant question, how to AI? Okay. Rather than just say it's there, it's sexy, it's attractive, let's see what it does. It's to really critically ask, what can it do musically? Okay. Now, some of the immediate answers, or since I'm working with body movements, could we do forms of gesture recognition, like we do handwriting recognition or like we do voice recognition? And that's all very, very highly advanced today and very much in everyday life. If we talk to Siri or to Amazon Alexa, or just to try to get the tax people on the phone in the telephone menu system, okay? That kind of classification, however, is not that creative, is it? Because somehow the classification is unitary, okay? We have to actually take all the different voices of people saying, hey, Siri, okay? And just sort of collapsing that into a single command. Okay. Now, gesture in music, okay, may be identified as this gesture versus that gesture. They might be unitary, but gesture is a continuous, okay, action. Musical gesture might not be able to be segmented so easily, because we might be starting the next gesture while we're still finishing the previous gesture. Okay. So rather than think about recognition and classification, I was interested in mapping and association, mapping then directly somehow the body states, the body's movements to sound output. And so here, a regression approach using neural networks seemed appropriate. The question then is a question of what data. I'm a musician, I've got my body, I can train a neural network. With deep learning technologies, we're immediately invited to think about big data, to think about populations represented in data sets. Okay? But how might myself as an individual performing composer be able to capture that much data? Or if I do, is it relevant if I'm trying to do a personal performance myself? So here we start to run into questions of what does big data actually represent? Does it represent everyone, or does it normativize everyone? Okay. And so here in a practice such as music, my claim is that in fact, one size doesn't fit all. I'm quite interested in what my body is doing in a specific situation on stage. And so in this case, I'm interested in questions of small data. Okay. So now, to think about why machine learning might be helpful in this mapping then of the body to sound synthesis, okay? We can track gesture through traditional systems such as motion capture, where we're observing the body, or with the physiological signals that I'm using, we're looking at gesture at the source of corporal movement. And so, in a sense, we're looking at performative intent, okay, by tracking the EMG. And in the current project that I'm running in France called BBDMI, Brain Body Digital Musical Instrument, I'm working for the first time with a neuroscientist in a brain-computer interaction setup where we'll hybridize muscle and brain for musical performance. Okay. In either case, whether it's EMG alone, EEG, or EMG and EEG together, we're looking at gestural of the body, perhaps brain states, then map to digital sound synthesis. And the reason that machine learning could be relevant here is, in fact, because these physiological signals that we're getting are very messy. Okay? If we're tracking multiple muscles across different limbs, if we're hybridizing brain and muscle, we're dealing with multidimensional, okay, information spaces. The fact that it's the live body means that this flow of data is also very messy. So here then machine learning might help us, okay, in a case where manual mapping might be difficult. Now that's how machine learning might serve a musical case. Okay. And here, the converse, I'm interested to see what is it about music that might make it an interesting, okay, research avenue for machine learning. Why might music itself represent a challenging use case for machine learning technologies? And as I said, in the question of unitary classification, we may not be able to segment gestures so easily. One gesture may lead into another. Similarly, we have a question of expressivity in music. Rather than trying to do handwriting or voice recognition to find a canonical word or letter in all the different ways that people might write that letter or say that word, in music, we're interested to celebrate all the different ways in which people might express themselves, ostensibly saying the same thing or playing the same phrase of music. So in music, the same gesture may be quite different when it's played by one user or another. And we don't want to collapse this difference into the recognition of a canonical gesture. We're interested to take the variation across users, across performance of all the different ways that the same music can be played. That sameness may be, in fact, embedded in the same user. One day I may perform, if I'm playing a sonata, in a certain way. The next day, if I'm practicing, I may play it differently. If I go on stage, I'm nervous, and maybe the same composition, the same piece, but suddenly I'll play it differently. I'll play differently in a recording studio than in a concert hall. So the same, again, is not really the same in music. Okay? And so there's a need, okay, to track this, what I call expressive variation, and not create invariant systems, but to figure out systems that are able to track and adapt to expressive variation difference. The other challenge in music is that we need real-time systems on stage. If they are to be performed, the system has to be reactive to the performance as it's taking place. Okay? Now, in a classification scenario, we get the highest classification success rate when we've got all the data. So if we look at the pianist down below and we're trying to recognize that sort of phrase and gesture, okay, of course, once it's done, we can confidently say, okay, you've done this sort of loopy gesture. Now, the problem is, in most musical cases, if we report the gesture after it's over, it's too late. Okay? We would like a responsive system that is able to track gesture and identify it somehow as it's happening. So we need something that's a system that responds during and not after the input is finished. This leads to the need to create systems that have minimal latency, minimum delay, and the development of algorithms that are able to do forms of recognition with incomplete data or early recognition. On top of which, in the unitary classification case, we're interested not to be told that this is gesture A or gesture B. Okay? One gesture may flow into another, or gesture A and gesture B might be happening somehow in parallel. Okay? So we need forms of continuous output instead of brittle classifiers. Okay, we need probabilistic models that somehow tell us, oh, it's a little bit of that. It's looking this shape. It looks like that, but also a little bit like the other. Okay? And this gets us into then rich multidimensional musical information spaces. The last challenge that I think that makes music an interesting case for machine learning science is that there's often no ground truth. Okay, now in developing algorithms and finding solutions, engineering solutions for complex information problems, to base oneself on some fundamental ground truth is often a safe way to go. Now, in a creative pursuit such as music, this ground truth may be shifting, may not even exist, or may be represented with very incomplete or small data sets. Moreover, given that they're creative tasks, we're not able to define our problems in such clear engineering terms. And if you talk to any musician or an artist, they say, well, I want to do that. I'm having trouble doing that. They describe the problem to you, and then you try to help them solve the problem. And they say, well, that's not really what I wanted to do. I want to do something else. Now, is it that they don't know what they're talking about? Well, maybe yes, maybe no, but I think the creative process anyway is one of ill-defined problems and sort of shifting goalposts. And the shifting goalposts lead to evolving goals. As soon as you got something, you want something else. And so an algorithm or a machine learning system needs to follow us, needs to adapt as our goals change. So we have a number of tools available to us that we use also in our teaching. Some of them go back 20, 25 years, in fact. And so some of the early AI machine learning work that I talked about historically is still highly relevant. So back in the day when I was at Sony, we were exploring a nice code library for machine learning from New Zealand called WakeUp. Okay, that encapsulated a number of early machine learning algorithms, where there was the k-nearest neighbors, some early neural networks, etc., in very useful ways. I'm hearing someone's microphone somewhere. And then it's a colleague, Rebecca Febrink, who's very well known for having created the software called Wekinator. And why is Wekinator called Wekinator? Because it draws on the Weka library. Okay? So Wekinator, created in about 2010, makes use of the Weka library that had been created in 1999. Okay, we continue with this, and today, through some students and colleagues like Michael Zabinski working, we're able to wrap then the user interface that Wekinator provides to the Weka library in the form of a plugin for the commonly used environment Max. And so we have a Max object, keeps changing name, but Rapid Max was the name in one version. Mike Zabinski has rolled out a couple of new versions of this, but essentially we're able to work with the forms of interactive machine learning that Rebecca Febrink made available in Wekinator, but without having to run an extra piece of software and to set up communication, inter-application communication between a musical environment like Max and a separate machine learning software like Wekinator. All this then can be within the Max programming environment itself. Okay. In all cases, what Rebecca applied to music was that she took the concept of interactive machine learning as it had been developing, okay, and made it available to us musicians as a kind of workflow. Okay, and so the interactive machine learning workflow is one where the classical machine learning rhythm of training and testing, okay, recording data sets and running the recognition or the regression, okay, becomes iterative and interactive in that users are able to edit the data set. And by editing the data set iteratively, this is then creating a workflow that accommodates the musical creative process where goals can change, the goals evolve. And so in HCI, this puts the human in the machine interaction loop. So it's a human in the loop paradigm. Okay. So whereas traditionally we may have recorded a training set in the red box, trained an algorithm in the yellow box, and run the model and just took it for what it gave us. Okay, we're able to now make a loop, edit the training set to suit, re-record, retrain, and rerun. So at the risk of boring those who know this in a much more advanced way than I, but in a way to try to make this comprehensible for the musicians and artists in the audience for whom this is all very, very mysterious, I'm just going to show a couple of animations of very, very basic schematized regression and show how interactive machine learning makes this iterative. So this is highly simplified, but in a basic regression task, okay, we have an independent input variable that then will give an output variable, and we will record examples, okay, of input-output pairs, okay, to constitute our training set. So we may record one example, record another example, okay, until we've got a training set, okay, of a number of input-output pairs, X and Y. Okay. Clearly, in a real-world situation, this would be many more dimensions. Okay. And then we can train and generate a learned regression function, okay, to go through those points. Once we've got the regression function, we can then run the model, okay, and put in an input variable where we don't know the association to the output, and it's the algorithm that then reports to us if we have an input X at this level, then likely, according to the regression model, the output will be this green dot value Y. Now, if we do this with the interactive machine learning workflow, we can do this once and say, well, the regression model is sort of interesting, but it's not that interesting. I want to keep recording. So then we can say, okay, let's keep the training set that we've got, and let's add some new points. Okay. And we can train again. Okay. And we say, oh, well, that's interesting. I've got a sort of a more interesting model here. And of course, as it's getting interesting, we want even more. So we say, okay, we added one point, it got more interesting. Let's add another point. Okay. And then we edit again, retrain and run. And then suddenly all hell breaks loose. And we may get a regression model where, in fact, a new input coming in might actually cannot be reduced to one output value, but might, through overfitting, be more than one. Okay, so this is a very simplified kind of abstract representation of a problem we call overfitting. Okay, and so if we run into that problem, interactive machine learning workflow to the rescue, we can undo. Okay, so we can actually take that point away. Okay, editing the data set means we can delete the last recording, okay, and go back and say, in fact, what we had when we added that one point was perfectly fine. Let's go back to that, retrain and run, and we've got our nice model. Okay. So how do we then deploy this in performance? Okay. These are very, very simple neural networks, okay, of the sort that the Weka library supported 20 years ago, okay, with an input layer, a hidden layer, and an output layer. Okay. The RapidMax object in Max implements this, okay, and we have a set of a kind of Max patch around it that allows us to record the data set and indeed implement the ability to edit the data set. And this is thanks to Francesco DiMaggio, who's working on the BPDMI project. Okay, but in any case, this gives us the ability to create regression models directly in Max and have multidimensional input and multidimensional output. So in my case, using the EMG in music, what are these? So in very simple terms, we can say it's muscle in, audio out. The input coming from electrodes, here we see in the green oscilloscope-like waves, the messy physiological signal from 8 channels of muscle. And we would like to associate this somehow with a corpus of music here represented in the audio waveform you see in red there. The red is not supposed to be a solid color. There's supposed to be vertical lines where the audio has been segmented into grains, okay, and analyzed for audio descriptors. So we have multidimensional in coming from the body, multidimensional out in sound, all happening in a descriptor feature space. We are looking at analysis of the EMG to extract gesture features, and we'll use the neural network to associate certain postures of the body with certain grains of sound, and the grains of sound having the auditory metadata, will be then the multidimensional output data feature space that we see there is 18 audio metadata dimensions. Okay, just so happens we had 19 gesture features driving 18 audio metadata features. They're nearly the same sort of dimensionality, but they don't have to be. Okay. And we've got a max patch then that associates EMG in and audio metadata out. This is using a concatenative granular synthesizer it's based on content metadata developed at IRCAM called Catard. So my question as a performer then is to say, well, how to perform these things? Okay. I don't want to give this talk every time I give a concert. I'm happy to give little bits of explanation. Okay. But really, as musicians, we feel that music should speak for itself. But then if the musician says, well, I'm using the magic of AI, and I'm going to play with a huge corpus of data, of audio metadata, and an AI algorithm is going to create a magical regression model, and I'm going to go on stage with this model. What will the audience really understand? Okay, and so here then comes the question of, do I go on stage with a pre-trained model? Okay. If so, the audience needs to take that on face value. They have to trust the claim that that's what I'm doing because they don't really see it. Now, there's that question of how apparent is the process. But there is also this question, as I said, that the same cannot be the same depending on context, depending on conditions. So if I've trained a model of gesture to audio metadata in the studio, in rehearsal, the moment I go on stage, the conditions might change a lot. Perhaps that model won't be so effective, okay, or might not be able to follow me in the change of context, okay? And in that sense, on stage, if I experience that I'm not finding the right sounds, what should I do? Should I try to adapt to conform to the model, despite the fact that the stage setup would allow me to make the same gesture in a much different scale? Okay. Should I feel constrained in that way to try to reproduce the rehearsal conditions in order to perform the piece? Okay. These are the questions and the problems that arise in working with pre-trained models. Okay. Instead, I'm interested to expose the process, okay, of a human performer working with a machine learning algorithm, let's say an intelligent agent, where the human has one of the tenets of HDI, agency over the data system, and where the machine learning algorithm is itself an agent. Okay. Can we create a conversational rapport or dynamic in performance, okay, and expose then this dialogue to the audience, and perhaps to expose the very interactive machine learning workflow itself, to expose the training process. And so the performance that you'll see, and I'll play a little clip if we have time, starts with a blank data set. I start with a tabula rasa, okay, a blank slate, and the beginning of a piece will be very static, quite boring, as I associate single postures of the body with single grains of sound. But as I do this with a second posture and grain, a third posture and grain, then start to train the neural network, I will then create a continuous gesture sound space that I'll be performing, that then represent the conditions on stage at that moment. The composition then that ensues is a further training and editing and of the data set to more posture sound pairs, and then the information space that the regression model is dealing with gets richer and richer. So all this then creates a living system where the model that I'm training up reflects the situation at hand, reflects the moment. The human agency in conversation with the machine learning agent creates in HCI what scientist Wendy Mackay calls a co-adaptive system. And then for myself as a musician, this becomes interesting where I recover the excitement of musical performance, the sensation and risk, the danger that what I'm doing on stage is literally training the neural network as I go. Okay, will it work? Will it not? I go on stage with a blank slate and end up with a fully trained model, and the audience sees this whole process unfold. So I'm going to finish with a video again from YouTube. So let's hope it works. This is online. It's a performance I did at a venue in London called Eclectic last year. And if people are interested to check it out, you can on YouTube look up the title here. I played with an artist called Avisluta. She played the first part of the concert and I played the second. And that's the title of the YouTube video. We're going to come in the middle and you'll see, if you go to that video, I do give a short explanation of the system. But in the interest of time, I'm going to cut straight to the chase and play a few minutes of this piece called D-Learning, where the corpus is a piece for chamber orchestra that I made a number of years ago. That is the corpus within the CAD art synthesizer, and then you'll see me train up the neural network in performance. Still in the training phase, we've trained key on our platform running. And there's 23 points now about the neural network. Now train up another front, I think. Still. There's a new point. Got it. Okay, and it goes on to the climax, etc. But for the interest of time, perhaps we'll keep it at that. And for those who are interested, it's on YouTube. So let's see. There we go. And that's it. So thank you very much. Hope we have some time for questions. I'm trying to get the Zoom interface back.
Yes, we should have some time for question. I'm also on double screen, so I'm trying to get myself. Do we have any questions from someone?
Yes, actually, I would love to ask about the tempo in the piece.
Yes.
It felt like, was the tempo pre-coded as something fixed for the piece, or is it responding to your gestures?
Both. So yeah, thank you for the question. And so it's musically acute because there's clearly a kind of static element, and then the music speeds up at some point. So what you heard in the beginning, as I said, I'm starting to train the neural network, or starting to record my data set, okay, by associating single positions of the body to single grains of sound. Those grains of sound are indeed of fixed duration in this case. I think there are 250 milliseconds, which gives us this sort of 120 BPM kind of rhythm. Okay. And then I did that with a second and a third. So the grains are different, but the grains of the same size. They're just in different places in the timbral information space. But if I tried, as a musician, if I kept going with all that, it would become temporally quite monotonous. And also not just temporally monotonous, but if all the grains played all the time, it becomes a bit like a machine gun a situation. So by the time I got to the third example, with the higher sort of string sounds, I think, I start to add other elements of interaction, okay, where although the machine learning is recording the 8 channels of EMG and associating them with a grain of sound in the information space, I'm also able to do other things with the EMG. So I took the sum total of the 8 channels on the arm and made a simple mapping to synthesizer amplitude, for example. So then I'm able to squeeze and start to create those swells, okay? And then similarly, a little bit further on, once I've got, I'm running the regression model and things are getting quite complicated, to avoid the machine gun kind of tempo, and this is what your question is about, I start to take another feature of the EMG, or the other arm, in fact, and start to modulate the grain size. And so that's when you heard sometimes the music speed up and slow down and so forth. So in that sense, machine learning is one of the elements in the piece. It's the main element, but it's not an absolutely purist piece. I'm allowing myself to use other simple direct mappings for things like the dynamics and the tempo.
Thank you.
Other questions?
Anyone? Oh, yes. Anyone? Yeah. Well, I don't know who came first, but Nicola.
Hi, thank you. Oh gosh, it's very dark in here. I just realised, one moment. Hello, back again. Yeah, it was just to carry on the conversation about the mappings, really. So that was really interesting. So you were saying, I suppose I was wondering whether there was a particular, I don't know, theoretical basis for the cross-modal mappings that you were engaging in. So, you talked about tempo and loudness, timbre space, but particular, cross-modal mappings with embodiment, or perhaps with other kinds of cross-modal mappings, and to what extent that influences your practice.
Yeah, so I do think of these in theoretical terms at different degrees, depending on what mood I'm in and depending on what the work at hand, whether I'm trying to write a paper or write a piece. But at the moment I go on stage, I think musical satisfaction for myself is the most important thing. And so if I'm working with physiological sensing, I'm really interested in the phenomenological corporeal effort and the kind of system response that comes back from that. And in my time, let's say, because I'll be 60 years old next year, I've been doing this kind of thing for a quarter century or more, well, quite a bit more, in fact. Digital systems didn't have the kind of fluidity of response. And so at the outset, I was most interested to get as analog as possible with the digital. And it was a very simple objective at the beginning, but it stays with me. And I think in the music that I create, to get this sort of visceral satisfaction to be able to squeeze sound out of a digital system, to take a digital system that doesn't have just a sort of a data ceiling, but that can go into overdrive or a saturation, is of interest to me. So then to find ways then where interpolation is not limited by interpolation, but that can create an information space that can go into forms of extrapolation beyond what you've trained, okay, is interesting. And that then brings the unexpected, the possibility for the system to blow up. And that, for me, recalled as a guitarist playing a guitar and trying to bend the note as high as possible, but without breaking it. And it's at that breaking point where there's an intense energy that emerges. And I'm looking for that kind of energy with digital systems. Now, so this all speaks to effort in interaction. I'm interested in Laban movement analysis, the kinesphere, and different sort of embodied ways to then, if not theorize, somehow codify these practices. So that's an important thing for me. Then in terms of multimodal interaction, each mode of interaction has its affordances. And so we'll draw upon environmental psychologist J.J. Gibson's theory of affordances and ways that the environment may offer a subject to act. I'm interested in the possibility of sound having affordances, and then composing sounds that have affordances that get my body to move in a certain way, or where the interfaces that we create, the instruments that we create, then have object affordances. Muscle interaction is good for this sort of squeezing and this immediate. It's a sort of a minimal latency system that's faster than observing the body with a motion capture system. We're using an accelerometer. But if we're to pair that with brain computer interface, that's much slower interaction. So to look at different temporalities of interaction in a multimodal configuration is currently what I'm looking at in the French project.
That's really interesting. Thank you.
Federico.
Atau, so I have maybe two questions, and I'm going to try to articulate them in a fairly reasonable way, but probably they will be hugely convoluted as I try to formulate what I'm trying to say. But
critical questions are welcome. You know,
yeah. No, so the first question I had was around how to put it, like the difference between human and machine learning. And in this piece, you've kind of like decided that you're going to do all of the machine learning on the stage.
Yes.
But what I would dispute is that as a human, you usually don't do that, right? And in fact, you've been doing this for, as you said, more than a quarter of a century. So I was wondering, firstly, to what degree the machine is then, in this case, at a disadvantage, because you have all of this embodied knowledge that that you've been training yourself and practicing for years and years and years. And then when it comes to the machine learning, you are, the machine is just learning in the while you're performing. So I was wondering, what, if you had anything to say about this, because it seems to me that if you wanted to have a more, let's say, equatable kind of like situation, then it is possible that then you would have to go through the more like deep learning routes. But I was just wondering, firstly, what do you think about this?
Yeah. Okay. No, that's a very good question. And then there is a question, well, do we need a situation of equivalence? It doesn't need to be a conversation of equals, because they're of different, completely different kinds of agents. Is the machine at a disadvantage? Yeah, that's a very interesting way to put it. And already to be talking about this here makes this conversation very different than the other kinds of conversations that are out there and popular myths about AI, where we wonder whether robots will take over the world, etc. And here we're talking about the machine at a disadvantage. The question of time, yes, I've practiced my system. I know my body in performance, much like a musical instrument. An instrumentalist who plays for a quarter century the violin will know the violin. And that's why I was very interested myself to take this time, to invest this time with one particular form of interaction for music, in this case, the EMG. Meanwhile, the machine learning algorithm, in this case, knows me only for the 10 minutes of the piece in some ways, right? Because I'm starting with the blank data set. But I would say that those two temporalities are not on the same level anyway. So, and it's not as if I know the machine learning algorithm for those 25 years. I know my instrument. The instrument is my body. Part of the composition includes the neural network. And so I would say that there is a human learning process going on, and this is the spontaneity and risk that I talked about. Okay. In as much as I can reliably train the machine learning algorithm to associate this posture, let's say, with the sound grain that I have already chosen. So the composition exists, and I know, in my corpus of sounds, these are the initial grains that are starting points. And on stage, I will sort of get into a space, find a place in my body, and train on that first grain. There's a second grain. I know what the grain is going to be, and then I'll find a posture to train on the second grain. Once I've done that with 3 grains and get into the first running of the regression model, there's always a surprise. And that's where the context, the space is different. How much my arm may have been trembling at the moment that I hit the record button for the training set means that the noisiness of the window within which I've recorded may be more or less than before. And so the system does respond in ways that are recognizable to me, but that are always somehow surprising and new. And I would claim that this is perhaps a musical dynamic, or a dynamic that we as musicians look for. We are able to reproduce pieces, play the same sonatas, but every time it's different. Or if we play the same string quartet with the same colleagues, but that the violist responds differently, the same piece can take on a different spontaneity at every performance. And without being didactic, I think in creating the system, I was somehow naturally looking for this kind of dynamic in my conversation with the neural network.
Great, thanks. I mean, yeah, what I would say is that, if you think about the process of training, you as a performer, have done a lot of training, way more than the machine.
Yes,
but that's just, that's just a
but no, and indeed, so in that question of time, this is where deep learning might become interesting, not to capture the widest population, okay, in data, but perhaps in your proposition, the deepest and longest time. So perhaps the only way to, if we're looking for the equivalence, then with the 25 years I've invested in my body as instrument, if I had had a deep learning algorithm, okay, at every rehearsal session, over these 25 years, in a longitudinal study, creating a 25-year-old data set, then perhaps we start to get to, then deep learning becomes interesting for me. But I haven't, 25 years ago, I didn't have deep learning algorithms at my disposal, but you've just given me an idea of what to do for the next 25 years if I'm still around. So thank you.
Great, thanks. Yeah, I'm gonna not do the other one because I think there's another person that wants to ask a question.
Okay, yeah, Juicy Caruso.
Hello, yes. Good evening, and thank you for this virtual meeting. So I was thinking, if with this machine learning, we can also involve the audience, if you think also to involve, for example, the audience in interactive performances, because now we are wondering how we can make more interactive the performances also by the public engagement. Of course, I think the process will be more complicated, maybe. So I was wondering if you think about this and how we can do maybe in the future also a performance with the public engagement.
Yes,
Thanks.
no, that's fantastic. In both Federico's case and Juicy's case,
yeah,
it gives new ideas for new projects. But
yes,
indeed, capturing audience response could be an interesting avenue. And there are some projects that have instrumented the concert space of the audience. Some researchers at the Sonic Arts Research Centre in Belfast worked on putting physiological sensors on people listening to a concert. Similarly, some colleagues of mine at Goldsmiths running the digital musicology, transforming musicology project, Tim Crawford and colleagues instrumented the concert hall of audience listening to an opera. And so we are able, with devices like the Empatica, that's come out of Rosalind Picard's group at MIT, the Effective Computing Group, very simple wireless effective computing devices that are able to do some very basic but rather sophisticated physiological measures. Yeah, Guido Orgs is a psychologist now looking at audience reaction, not in musical situations, but in mass spectatorship, like football games. Now, indeed, when you start to get that much data, okay, the opera concert hall, you might get a couple hundred that we might be able to deal with. Once we're in a football stadium, we may be dealing with thousands. When you're dealing with numbers like that and having to then cut through the data, make sense of the data, this is precisely where machine learning becomes useful and relevant. So then there's the question, musically, what would you do with it? And then what would the interaction be? What would the audience performer conversation that you're facilitating, what that would be? And this needs to be thought of in a musical and creative way.
Yeah, thank you.
Right.
Good. So I think we had a good conversation. We ran a little bit over time, but that's good to have this conversation. And so thank you, Atau, for a great talk. Good launch for the second half of our talks. And if you're interested, in a month, we're going to have another preeminent contributor in this field, Ian Cross, who's been doing a lot of work on music and data and music and science for quite a while. So he's going to be another interesting and very different perspective. That's the first Thursday of December, whatever that date is. So thank you all for joining us. And we'll at some point we'll upload also the videos from these lectures. And if you want, on our website, there are videos from the previous 6 that we ran last year. Thank you very much.
Thank you, everybody. And I'm very happy to have been able to do the talk, especially since last time there were problems. So great. Thank you, everyone, and hope to stay in touch with the network.